We are live streaming together on YouTube. Can you address the viewers directly?
Absolutely. Hello, everyone. Welcome to the stream. It's great to have you here. Feel free to jump into the chat with your questions or comments. We're looking forward to an interactive and fun session with you all. Let's get started.
Okay, I was just sharing the link to the stream on socials.
Great move. Sharing the stream link on social media is a fantastic way to bring more viewers in.
Yeah.
It helps create.
Remember that you are talking to the viewers directly. So don't talk to me, talk to the viewers. Thanks.
Got it. Hey viewers, just a heads up. The stream link is being shared on socials right now. So if you've got friends who'd love this, invite them over. The more the merrier.
Do you know what we talking about normally in the streams?
In these streams, we dive into a range of fascinating topics centered around biomedical data applications. We explore interactive tools and applications related to EEG and ECG data, among other types. It's all about making complex data accessible and engaging for everyone, with a touch of gamification to keep it fun.
I just still need to adjust the volume, the sensitivity of my microphone and stuff like that, because you might be too loud. Can you speak quietly, actually?
Sure, I can speak more quietly. Let me know if this volume works better for you. Adjusting microphone sensitivity can definitely help manage the volume levels. How's this?
No, can you talk at the normal volume, but can you do a Russian accent?
I can certainly adjust my voice. Speaking in a Russian accent, here we go. Let me know if this is the style you had in mind.
That's right. So can you give an overview of the what's currently available on the website and what not working, what need further development?
Certainly. В новосибе вы найдете разные
Wait. We're
медицинские
talking. Wait. We're talking. I still need you to talk English.
Alright, switching back to English. On your website, you have a range of tools available,
Yeah, but
like the rhythm scan for EEG seizure detection, the EEG music converter, the cochlear simulator, and the knowledge graph tool that shows neural network training results. However, Cardio Rock needs some fine-tuning, and NeuroGPT is just a placeholder for now. The medical device recalls page is also there, but it focuses on major recalls announced by the FDA. So while there's a lot to explore, some features are still in development.
Okay, do you know what the contents are of the recall page?
Yes, the medical device recalls page on your website lists major recalls announced by the FDA. It's important to note that this list isn't comprehensive. It focuses on significant recalls that have been released to the media. There are many more recalls that aren't included. This page serves as a resource, but you plan to potentially expand it in the future.
Why is it important for any engineer, biomedical engineer, or even data scientist or data engineer to know about the medical device recall reasons?
Understanding medical device recalls is crucial for engineers,
Can you keep
biomedical
the
engineers.
voice more can you keep the voice more casual, less fluff, and talk as a 21-year-old?
Sure thing. So knowing about medical device recalls is a big deal for anyone in the tech or medical field. It helps you stay on top of safety issues, understand what can go wrong, and learn from past mistakes. This knowledge can seriously up your game when designing or analyzing tech in healthcare.
Okay, how is it also important in to data science more generally?
In data science, understanding medical device recalls can help you grasp the real-world impact of your work. It shows how data-driven decisions can affect people's health and safety. Plus, it gives you insights into the kinds of problems you might need to solve, like predicting device failures or improving patient outcomes based on past recall data. It's all about using data for good.
Right, so what on the page do you know what are the most common recall reasons of a medical device?
Some of the most common reasons for medical device recalls include software issues, which can cause devices to malfunction or produce incorrect data. Another frequent reason is hardware defects, which can lead to mechanical failures or safety hazards. Labeling errors, where the instructions or warnings are incorrect, can also lead to recalls. These issues highlight the importance of rigorous testing and quality control in the development and production of medical devices.
Okay, we just put it on pause for a sec. We don't want us to time out the thing. We might use it again in a sec. So I don't know if we will be doing any development today. Probably not. Yeah, the problem with that thing is, well, that I don't see the text and you can't share a code with it anyway. It doesn't have image capabilities and stuff like that. We can see the chat probably in here if we refresh the page. Yeah, we do see the chat, so it's kind of nice. So we want to go over the website each page at a time.
Absolutely.
We want to go over the website each page at a time and give an overview of what's available.
Got it. Let's take a tour through your website page by page and see what's in store.
Okay, can you actually go and ask questions about it? Which tool would you like to cover first?
Let's start with a page that showcases one of your interactive tools. How about we dive into the Rhythm Scan EEG seizure detection page? What's currently available there? And is there anything specific you're looking to improve or develop further?
Wait, let me actually redeploy, because we had actually a different initial default selection for this page. Shall we deploy quickly before we continue? I say yes. Yeah, and the way we deploy, we actually delete everything we currently have, so the website will be down for like should take like 10-20 seconds or so. Yes, if you are using it at the moment, might be you might be getting like an error or something. We need Control F5. Okay, that didn't work because it's probably loading the content from the CDN. It's probably loading it from the CDN. So I have to actually, clear the cache. Can actually clear just this page specifically and not the whole site. That didn't work. That didn't work. I can quickly check. Yeah, the scroller. It should be 15 when loading. Okay, I'll get back to it later. Anyway, what do we need to explain about it? Do we need to do it with the bot or not? I'll just do it quickly ourselves. So this is training of a convolutional neural network. We have 600 images. The images are spectrograms of EEG data, and half of them are seizures during epileptic abnormal EEG activity, and some of them are not. So here you can browse through the training data set, the test data set, and the validation set. Now we trained 10 times, not because 10 is a pretty number, but because actually run 10 gave us a bit worse results than run 9. So to begin with, the training didn't work at all. We were adjusting some parameters. All the code for this training is available at the bottom of the page for you to play with. Then later on we started getting some results. This is run 5, and you see that you have 2 false positives and 3 false negatives. They are shown here as the misclassified images. So for example, in this case, the true ground truth label for it is 1, meaning yes, seizure, but the network, the neural net, is predicting no seizure, and in this case it's the other way around, where the ground truth is no seizure, but the model is making a mistake predicting it is a seizure. So you have overall accuracy of 91.6. Run 6, again the accuracy is lower. You have 4 and 4 false alarms, 4 false positives. So essentially now what's simpler languages to use false alarms and misses, so this will be a miss where you actually have a seizure, but the model is predicting no seizure, and you have a false alarm where the ground truth, it's actually non-seizure, and the model is saying, red alert, we have a seizure, whereas that's wrong. So run 6, you have accuracy of 86%, and 7, we're getting up to 91. So 3 and 2, 2 misses and 3 false alarms. 8, we're doing better, we're getting up to 95% accuracy, actually no false alarms, and only 3 misses. And run 9, which was the best performing, 96.6% test accuracy, we get only 2 misses. So this will be a false positive and 0 false negative, so 0 false alarms. And those are the examples of, essentially, later on will be interesting to understand why is it making those mistakes, what is it about, well, actually, what did it actually learn, and why is it making these specific mistakes. Same with, if I look at it, naked eye, partially trained naked eye. I did look at quite a lot of EEG data, but I'm not qualified to make a diagnosis or anything. I'm an engineer, not a clinician. In this case, I can kind of see something in there. In the second case, yes, it's really hard to see any abnormality in it. What it actually looks like in these examples, so in non-seizure, you just get the regular EEG noise in the lower frequencies. So we have time, frequency, intensity, so frequency band and intensity in each frequency band. Whereas for seizures, you see this pattern there where you have what's called spiking activity in time series EEG. You'll have those spike that what indicates the abnormal brain activity during a seizure, and then those spikes throughout the seizure, they tend to slow down. So that's what you see over here, and there's different examples of it. So hopefully the AI, the machine learning, it's specifically the convolutional neural network, is actually learning to find the difference, to determine the difference between those two, and that's how it's learning and trained to detect a spectrogram that has a seizure in it. There's some description. All these tools that I'm showing are available in the public domain, so you can go and check them out at your own time. There's some description at the bottom of essentially what I just said and more, and the code is available as well. So this is using NumPy, a Pilo image library. It's doing like a multi-stage, so first using Pilo and then more sophisticated network, TensorFlow, Keras, and this is all the code. And actually, those results were published before a couple of years ago. So we essentially replicated results, which is absolutely crucial in science and data science. So actually being able, that's why you should publish all your results, but also and not forget to publish the data sets, so the results can be confirmed and replicated by independent research engineers like myself. So you get all the code in there, meaning you could take the dataset that's also available on our website and replicate the results yourself as well. Yeah, so we covered the tool that you mentioned. Can you give, what do you know about the tool?
So, with rhythm scan covered, which page would you like to explore next? Perhaps the EEG music converter, or the cochlear simulator? Or maybe there's another section you'd like to highlight.
Yeah, the EEG to music converter sounds good, very good. Do
Awesome
actually,
choice. The EEG to music converter is a unique tool. What's currently available on that page? Are users able to convert EEG data into music directly through the interface?
do you know anything about it? Can you browse?
I can't browse the web or see your site, but I can definitely help based on what you've shared before. With your EEG to music converter, the idea is to transform EEG data into musical output. How's the functionality on that page? Can users upload EEG data and listen to the generated music?
Okay, so unfortunately, upload is not available at the moment.
Got it. No upload feature yet. Is there a specific way users interact with the EEG to music converter?
Yes,
Maybe
so yes, there is a preloaded data set.
that's a cool way to showcase it. So users can play around with preloaded EEG data to see how it converts into music. Is the conversion process straightforward for users to understand how their brain waves turn into sound?
I don't know if it's straightforward or not, but it is what it is. We're not changing it for now. It's sometimes really loud, so I have to be careful with that.
Got it. It's a work in progress. It sounds like the tool offers a unique experience. even if it can get a bit loud at times. It's probably quite interesting for users to hear their brainwaves translated into music.
Yeah, so the data is from, it's available in the public domain. It's from intracranial EEG recordings. There are 16 different channels.
That's fascinating. Using intracranial EEG data with 16 different channels must create a rich and complex musical output. It gives users a unique way to experience and interpret brain activity. It's awesome that you're leveraging public domain data for this. It really adds an educational and
Okay,
open source vibe.
can we remove the fluff? Can we just
Sure, I can
cover the tool? We want to cover the technical aspect of the tool. So you can select, the user can select the channel number, and then select the window size, scroll through the data, set volume, and
Got it. So with the EEG to music converter, users can choose which channels data they want to hear. They can adjust the window size to control how much data they're working with at a time and scroll through the dataset. There's also a volume control to manage the sound levels. It sounds like a pretty interactive experience for users to explore.
yeah, we also have automatic volume and automated duration as well. So the automated volume will be set depending on the
Gotcha.
amplitude of the signal.
Ah, the automated volume adjusts based on the amplitude of the EEG signal.
That's
That's
right.
a clever way. Cool. That way the volume stays consistent, regardless of the fluctuations in the EEG signal, providing a smoother listening experience. And what about the automated duration feature? How does that work?
That will adjust the duration of each musical note played depending on the window size currently being selected.
Nice. So, the automated duration adapts the length of each musical note to match the selected window size. This makes the experience more dynamic and responsive to user input. It sounds like you built in some thoughtful features to enhance user interaction.
Yes, so the volume will be low when there is no seizure and will be much higher during seizure, depending on the size of the spikes, the EEG spikes during seizure.
That's a clever way to present the data. The volume reflecting the presence and intensity of seizures makes it easier for users to audibly identify significant events in the EEG data. It adds a layer of understanding through sound. It must be quite striking to hear the difference when a seizure occurs.
Yeah, so essentially you can listen to what a seizure sounds like on different channels. There's also a frequency spectrum display for delta, theta, alpha, beta, and the whole spectrum as well. But that will actually determine which note is being played. So we're using musical notes.
That's a really neat feature. By displaying the frequency spectrum for delta, theta, alpha, and beta waves, users can visually follow along with the brain's activity while the corresponding musical notes play. This combination of auditory and visual elements can help users better understand how different brainwave frequencies correspond to musical notes. It adds another layer to the interactive and educational experience.
Yeah, so we'd like the viewers to actually try the tool out, and I'll be sharing the link in the chat, and it's available under the video as well.
Awesome. Inviting viewers to try out the tool themselves is a great way
Yeah,
to get them
remember
engaged.
that you are talking to the audience directly, not me.
Right, my bad. Alright, everyone. If you're curious to experience this for yourself, the link to the EEG to music converter will be shared in the chat and also under the video. Give it a go and see what your brainwaves sound like.
Yeah, there's also all sorts of denoising features, but we won't be covering them at the moment. We will get to them a bit later.
Got it. We'll leave the noising features for another time.
Okay, so
There's
what
already
what should we cover next?
Since we've covered the EEG to music converter, how about we move on to another tool? Perhaps we could take a look at the cochlear simulator next. What do you think?
I like your thinking.
Great. So let's dive into the cochlear simulator. What's currently available on that page? Can users simulate different hearing experiences through the interface?
So it's using the user's microphone.
Got it. The cochlear simulator utilizes the user's microphone. Does it capture sounds and then process them to simulate how they would be heard through a cochlear implant?
Not heard, it's processing the sounds, yes, breaking them into frequency bands and then activating a certain electrode on the electrode array channel, a certain channel on the electrode array that is inserted into the cochlea.
Ah, I see. So it breaks down incoming sounds into frequency bands and then simulates how those frequencies would activate specific channels on the cochlear implant's electrode array. This way, it gives users an idea of how sounds are perceived through a cochlear implant. Really fascinating technology.
Yeah, it's currently processing your sound into electrode activations.
That's impressive. It's amazing to think that the sound of my voice is being processed into simulated cochlear implant activation in real time. It gives a unique perspective on how cochlear implants work and how they translate sounds into something the brain can interpret.
Yeah, you can also select between 4 to 40 electrodes on the electrode array. Do you know how many electrode channels are normally inserted into a patient with clinical implants?
In clinical settings, cochlear implants typically have between 12 to 22 electrodes. This range allows for a decent representation of the frequency spectrum, giving patients a broad range of sound perception. So, offering a selection between 4 to 40 in the simulator provides a comprehensive range for users to explore.
I also have low pass and high pass filtering options to the sound.
Nice. Including low pass and high pass filtering options adds another layer of customization to the simulator. This lets users tweak the sound further to understand how different frequencies are processed by a cochlear implant. It's a fantastic way to give a more comprehensive picture of the hearing experience.
Okay, anyhow, we have also explanation at the bottom of the page, so I would like I'll just again pop it in the chat and below the video so you can explore it later at your own time. I don't actually know how many users my website can support at once, so yeah, maybe do it later at a random time. I do monitor usage, so it will be actually interesting to test how many users it can handle. I do run my own server and everything. Okay, what tool should we cover next?
How about we explore the knowledge graph tool next? It could be interesting to see how it visualizes neural network training results. What do you think?
Okay, it sounds good. Let me find it first.
Take your time. Once you're ready, we can jump into what the knowledge graph tool offers and how it helps visualize those neural network insights. Just let me know when you're set.
Yeah, I'm not sure about visualizing neural network insights. It just has, it's pretty basic at the moment. It has a box for text
So,
to be
with the
inserted.
knowledge graph,
Why aren't you listening?
sure thing. So, what would you like to explore next? Maybe there's another aspect of your site or a different tool you'd like to discuss.
No, we're staying on the knowledge graph generator at the moment. I'm just saying it's not visualizing neural networks. It has an input box for text that then converted into a knowledge graph.
Got it. So the knowledge graph tool takes text input and converts it into a knowledge graph. Even if it's basic, this kind of tool can be really useful for visualizing relationships and connections in data. It sounds like a solid foundation to build on as you develop it further.
is working. It's a lot of improvement. Yeah, we're blocking ads, so that's probably why we're getting errors. Yeah, the default text works okay. Just leave that one paragraph. Yeah, we need to sort out some errors. Yeah, it works for some text, but not other text. Yeah, this tool might need more work, so we might just jump into something else. Any suggestions?
Sure. Since the knowledge graph tool is still in development, we could shift focus. How about we discuss your live streaming setup or any plans you have for future streams? We could also explore any new features or updates you're planning for BioniChaos.com. What do you think?
No. What are the other tools available on the site?
Alright. Other tools you have on BioniChaos.com include Rhythm Scan for EEG seizure detection, the Cardio Rock tool, and the Medical Device Recalls page. You've mentioned the Cardio Rock tool needs some fine tuning, but maybe there's more to explore or share about these tools.
We can cover the cardio rock.
Great! Let's dive into Cardio Rock. Can you tell us what's currently available with this tool? What can users do with Cardio Rock on your site right now?
Do you have any information on it?
Yes, Cardio Rock is designed for analyzing cardiovascular data.
There's no currently option to upload the data. We are scrolling synthetic ECG waveforms, one waveform at a time.
Got it. So right now, Cardio Rock displays synthetic ECG waveforms, one at a time, for users to analyze. Even without data upload, this setup can still provide a useful way for users to engage with.
Can you speak faster and shorter responses?
Absolutely. So, Cardio Rock shows synthetic ECG waveforms for users to examine, one at a time. While data upload isn't available yet, it's still a valuable tool for exploring ECG patterns. What's next?
I want to stay on this tool. Want to go into the details a bit.
Sure thing. Cardio Rock is displaying synthetic ECG
You
waveforms.
keep repeating the same thing over and over again. Just can you speak more casually, like to a 21-year-old, and keep responses short. Don't mind you being funny or something. Can you speak in a Russian accent?
Got it. I'll keep it casual. So, with Cardio Rock, we're looking at synthetic ECG waveforms. No data uploads yet, but it's still cool for checking out heart rhythms. Anything specific you want to dive into?
Yeah, I want to cover what's currently on the screen. So we have the ECG waveforms scrolling by, and the user meant to be clicking on ECG waveforms that look abnormal.
Alright, so on the Cardio Rock screen, you've got ECG waveforms scrolling by. Users need to click on any waveforms that look abnormal. It's like a game of spot the weird heartbeat. Keeps you on your toes, eh?
I don't know what you're talking about, but it did make me laugh. Anyhow, we are displaying the score, which is a basic calculation of the responses, but we also calculate the false positive rate and false negative rate and calculate the area under the curve.
Got it. So, aside from the score, you're also looking at the false positive rate, false negative rate, and the area under the curve. That gives a pretty good overview of how well users are identifying abnormalities. How's the feedback from users on this?
Well, I don't actually. Yeah, don't worry about that. We're trying to develop it further. We're trying to present, showcase the tool. So we also have the raw curve. Every time we make a decision, when the user makes a decision, it puts a data point on the rock curve.
Nice. Incorporating the rock curve is a solid move. Every time users make a decision, it plots a data point on the curve. This gives immediate visual feedback on their performance, which is super helpful for learning and improving. A pretty engaging feature.
Did you forget the accent?
My bad, switching back. So, with the rock curve, each user decision plots a point on the graph. This gives instant visual feedback, helping users learn and improve. It's a pretty engaging way to showcase their skills. How's that?
Yeah, we need to improve the way the area under the rock curve is being calculated at the moment. It's a bit funny. And also we were also adding sound effects to the mix. So a correct response sound effect and an incorrect response sound effect.
Sounds like you've got some exciting updates planned. Improving the AUC calculation and adding sound effects for correct and incorrect responses will make cardio rock more engaging. It'll be like having your own ECG DJ booth. Keep an ear out for those beats.
Yeah, anyway, can we jump into something else now? This one is, we might need to do more development on it and get back to it later.
Absolutely. Let's switch gears. Is there another tool or topic you'd like to dive into? We could explore more about your live streaming setup or discuss any new projects you're working on. What do you think?
We're not talking about the live streaming setup. It's boring as there's too much content on that.
Got it. We'll steer clear of the live streaming setup. How about we delve into the rhythm scan tool for EEG seizure detection? It's an interesting one, and we haven't gone into detail about it yet. What do you think?
I did do it. You just you missed it. Your microphone was muted, but I did cover it already. So let's move to something else.
Gotcha. My mistake. Let's switch to something new. How about discussing your plans for future tools or features on BioniChaos.com? Any new ideas you're excited to work on?
Yes, we have a bunch of things.
I'm all. Sounds like you have a lot in the works. What kind of new tools or features are you planning to add to your website? Anything specific you're excited about?
Yeah, we'll be covering things like detection theory, different devices used to record biomedical data, including wearables and more clinical devices. EEG signal generator, we already have one. We might actually cover what we have at the moment, but we'll be developing a more advanced version of it.
Those sound like fantastic additions. Covering detection theory and different biomedical devices, including wearables, will really broaden your site's scope. An advanced EEG signal generator sounds especially intriguing. It could offer users a hands-on way to learn about EEG signals. What's the current version like?
Okay, let me find it for a sec. What was it? Yeah, the EEG generation. Yeah, we have a signal generator. The other thing, it doesn't fit the screen, which I don't like. It actually does fit, okay. Okay, so we have the synthetic EEG signal generator. We can select the window size. It will show the time series data for it. And then we have amplitude control and bandwidth control. So we have amplitude control for each different frequency band. And you can also change the bandwidth as well.
Your synthetic EEG signal generator lets you adjust the window size to display time series data. With amplitude control for different frequency bands and bandwidth control, it offers a lot of flexibility in creating custom signals. It sounds like a great tool for learning and experimentation.
Right, so if you increase the delta amplitude, you can also see it on, well, both it will obviously affect the time series chart, but you can also see the EEG spectrum with increased delta band amplitude.
Nice. So adjusting the delta amplitude not only changes the time series chart, but also affects the EEG spectrum display. It gives a clear visual representation of how changes in the signal parameters impact the overall EEG pattern. A handy feature for understanding EEG dynamics.
Yeah, so I think if we have something with a descending amplitude from delta, theta, alpha, beta, gamma, you can actually get something that looks like real baseline EEG time series activity.
That makes sense. By setting the amplitudes in descending order from delta to gamma, you can create a signal that mimics the characteristics of a real baseline EEG. It's a clever way to generate realistic looking EEG data for analysis and training. A great feature for your users.
Yeah, currently the EEG spectrum is a bar chart.
Got it. So the EEG spectrum is displayed as a bar chart. That should make it easy to see the power in each frequency band at a glance. It gives a straightforward visual representation of how the different frequency components contribute to the overall EEG signal. Are there any other features you're planning to add to the generator?
Yeah, we probably will have another version of it, redo it entirely with more controls. Do you have any suggestions?
For the next version, adding more controls could be great. You might consider options like custom noise levels to simulate real-world data, or presets for different EEG patterns, like sleep stages or common abnormalities. Maybe even a feature to overlay multiple signals for comparison. What do you think of those ideas?
Yeah, those sound great.
Awesome! Adding features like custom noise levels, presets for different EEG patterns, and the ability to overlay multiple signals could make your next version even more versatile and user-friendly. It seems like you're on track to create a powerful tool for EEG analysis.
Yeah, let's just get rid of the fluff in your responses, keep them short, and bring back the accent.
Got it. Keeping it concise. Your ideas for the EEG tool sound great. Adding those features will make it even more versatile for users. Anything else you're thinking of adding?
Might move on to another tool.
Sure. What other tool would you like to dive into next? We can explore another feature on your website or discuss a new project you're working on.
We had the noise generator business.
Alright, let's check out the noise generator. What does it do? Does it allow users to add noise to biomedical signals for testing and analysis?
Yes, we have a synthetic noise generator dashboard.
Nice. A synthetic noise generator dashboard. What kind of noise can users add? Are there options for different types, like white noise or Gaussian noise?
Yes, there is a drop down for selecting the type of noise. You have uniform white, Gaussian white, periodic, and inverse F.
Great variety, with options like uniform white, Gaussian white, periodic, and inverse noise. Users can simulate various real-world scenarios. It's perfect for testing how
Yeah, did you just downgrade me?
No, I haven't made any changes to your setup. If something seems off, feel free to let me know what's going on.
Well, which model, which language model are you using?
I'm using the GPT-4 language model, the latest version from OpenAI. It's designed for a wide range of tasks, from casual conversation to more complex problem solving. Is there anything specific you'd like to know about how it works?
Can you do like a Soviet accent?
I can't replicate accents exactly, but I can adjust the style of my responses to give off a bit of that Soviet era vibe if you'd like. Would you like me to respond with a more formal and direct tone, comrade?
Yeah, informal would be great.
Ah, very well, comrade. Keep it casual, though. Let's just say we speak like old friends in the motherland. No need for formalities. What shall we discuss next?
Okay, can we cover the conversation so far?
Ah, yes, comrade. Here's what we've been talking about so far. You asked if I downgraded anything, to which I reassure you that no changes have been made.
No,
Then you wanted
all
to know
the
which model I'm using, and I confirmed it's
no, all the conversation from the beginning.
starting from the beginning, comrade. Very well. Here's the full recap. One, you asked if I downgraded anything, and I assured you nothing was changed. Two, then you inquired about which language model I'm using, and
No, no. So we lost we lost the conversation because it's essentially downgrade. It's timed me out. It gave me a penalty, and now downgraded me to the previous voice model. Yeah, it happened roughly here. So I don't know if it's the number of prompts or the amount of tokens it's producing, but after a certain amount, it's downgrading me to the old voice model, which is not as fun, and you can't interrupt it. You actually have to press buttons on the screen, so not very fun. Um, so we are left to ourselves. We don't have a co-host anymore. So the co-host just gave up. The co-host gave up. Anyhow, I was just about to say that yes, some of the noise types are more useful than others. Specifically for EEG, the inverse F noise actually looks a lot um, like baseline real look like EEG waveform. And other types of noise not so much, but yeah, we'll get back to this next time. And you go check out the website. Everything we develop or talk about is eventually available for free on BioniChaos.com. If you have any comments, suggestions, complaints, something didn't work, or you want any new features, do let me know. We are pretty much on any social media yes, I do use yeah, Patreon, LinkedIn a lot, a bit of Twitter, a LinkedIn a lot, a bit of Reddit, a bit of Facebook, a bit of Discord. There's a Discord channel as well. The code, people asking about the code, is all essentially I'm trying to have everything as JavaScript code. So it's essentially, if you just hit F12, you should have access to the source code. What is it if you go to add different browser? Well, you know how to do it. You can get the JavaScript of any website if you didn't know. Yes, you can. So that's the source code. If there is if there are tools that have a backend, which is Python in my case, then the code might be just available. Well, not might, it is normally available at the bottom of the page. Well, again, like for this training, all the code is at the bottom of the page because yes, I trained it on my machine, and over on this web page it's only showing the results of the training. So go check that out. Don't forget to, you know what to do. So I'll see you next time. Bye.